Welcome to projectile motion. We are going to solve another question based on projectile motion. So the question goes like this. They're saying a catapult launches a rock at a castle hole. The rock is launched at an angle of 45 degrees with the speed of 22 meters per second. The castle wall is 45 meters away and is 20 meters high. How does the rock make it over the wall? So this question is just simple. They're trying to ask us to say, will the will the rock reach on the top of the wall or not? All right, so I have a simple illustration over this question that we can easily follow. We have, this is our wall. This is our wall. From here up somewhere there is our wall. Then the projectile, or rather a rock, has been shot from this given point. So it has to move like this. So now the question is, will the rock reach at this given point or not? So you can only determine that if you find, first of all, you need to know the height at which the rock is going to go. If it will have a height which is going to be above 20, definitely it will reach on top of the wall. But if the height is going to be less than 20, definitely you find that it can't even reach on the on the wall. So we have also two different methods that we can use on this same question. We have two different methods that we can use on this same question. Okay, so long you see such kind of a question whereby it is not making a symmetrical shape, the best way is to do like, you can just use a trajectory equation, then you have to specify which one you are going to find. So if I'm to use a trajectory equation, which is going to be like this, I'll say y has to be equal to x tan theta minus gx square over 2v initial square cos square theta. So whenever you try to use this expression, meaning that you need to find the height at which the ball is going to go. So in short, on this question, I'll use two different alternatives. I'll use trajectory equation by finding the value of y, the height to which the ball is going to go. So if this height is going to be above 20, meaning that it will land on the what? On the wall, or rather on the cliff of this same wall. But if it will be less than 20, definitely meaning that it can't even land on the wall. Okay, we start. So I'll use a trajectory equation. I'll say y has to be equal to x tan theta minus gx square over 2v initial square cos square theta. Just like that. Okay, remember, I just want to have the value of y. If I'm able to find the value of y, definitely that's when I will relate to say, is it above 20 or maybe below 20? So y has to be equal to, what is the distance in the x? Forget about this one. This is the height of the wall. Now we want to find the height to which this one is going to go. So since initially it is away from the wall on the distance of 45 meters, meaning that I'll use this same as the x distance it can move. That will be the same distance it is going to move. Remember, this question requires us to have an assumption to say, will the rock hit this wall or not? So we can only predict if we are able to find the height to which the ball is going to go. So I'll say 45 tan 45 minus 9.8. I'll say multiplied by 45 square over 2. What is the initial velocity? We are saying it has to be 22 square. I'll say cos 45 like this. I'll say square again. Now we can start. Y has to be equal to, we know that tan 45 has to be 1. 1 multiplied by 45, it is going to give us 45 minus. Okay, so for this one, I can punch on the calculator. I'll say 9.8 multiplied by 45 square. What answer are we getting? On top, we are getting 19,845. So divide this by. Down here, what answer are you going to get if you say 2 multiplied by 22 square? And I'll say open bracket cos 45. I'll also square this. So I'm getting 484. So if you try to divide this into the top part, I'll say 19,845 845. Divide this by the answer. So we are getting 41, 41. So meaning that y has to be equal to, has to be 45 minus 41. You find that y is going to be equal to what? 4 meters. So if you check, this definitely shows that the catapult can't even reach on the top of the what? On the top of the wall. That is the first method that you can use. Now the second method, are we going to get the same answer, which is this one, whenever you try to use the second method? Let's try to focus on the second method that I'm trying to talk about. We try to focus on the the second method that I'm trying to talk about. The second method, if you look at this thing, you'll find that this kind of object is going to be moving, or rather it will be having the velocity in y and also the velocity in x. That's what I'm from doing here. Meaning that first of all, you should be able to find the initial velocity in the x axis and also the initial velocity in the y axis. So we know that if we use these formulas written here, or rather these components, for y I'll take this, for x I'll use that one. So here I have to put 22, I'll say cos 45, then this one will be 22 sin 45. So if you punch cos 45, sin 45, you're almost getting the same answer. So these two, they are going to be the same. Reason being, they all have something which is also common. So we are getting 15.6 meters per second. That is this, the velocity both in y as well as in x, because they all have the same what, the same angle. And this angle, if you punch it, it also gives same things. Okay, now we're going to check that here. Like I said, if you have the horizontal range, the distance in the x-axis, meaning that for you to easily find what will be the time once it reaches at this given point, you can just do it like, you have to make sure that you take this distance and use it to find the time with the utility of this equation, which is x has to be equal to v initial cos theta t. So we have this one, which is 45, and also this part has already been found, which is what? That for me to find the time, I'll just say 45 has to be equal to 15.6 t. You divide by 15.6, and here 15.6, like this, meaning that t has to be equal to, so I'll say 45 divided by 15.6. What answer are we getting? So we are getting 2.88 seconds, meaning that that will be the time it will cover both in y as well as in x. Now for us to know what will be the height to which the ball is going to go, this is also going to apply like this. We are going to use this equation. I'll say v initial, now we are dealing with y, say minus 1 over 2 g t square. We know all these things where they are coming from. So what is the initial velocity in y and what is the time? That's what the trick is, and it is very simple. The velocity in y, which is the initial, we are saying it has to be 15. So y has to be equal to 15.6. What is the time? Multiplied by 2.88 minus 1 over 2 multiplied by 9.8. Now say multiplied by 88 square. So I'll start from this point. I'll say 15.6 multiplied by 2.88. We are getting, okay, y has to be equal to, if we just round off this one, we're going to get 45. Say minus, if you divide this into that, you're going to get 4.9 multiplied by 2.88. Say square. What answer are you going to get? Definitely, if you plug this and then you try to round off, you're going to get 41. If you try to subtract, definitely this also is going to give us answer as 4 meters. So it's just a matter of you choosing which one is the best for you. Thank you very much.